redistribution of charge. Here, let us take an analogous example of some liquids filled in two vessels of different size up to different height. Let this height is your H1 and this height is H2. This height is H1 from here to here, and this height is here H2. Here this is equals to H2 and this is H1, and this is any height, arbitrary height H dash. Let this height is H dash height. These are, here there is valve. इस वाल्व के थ्रू ऐसे रखा गया है कि द डिफरेंट हाइट है, लेकिन जैसे ही इस वाल्व को हम क्या करते हैं, ओपन कर देते हैं, लिक्विड स्टार्ट्स फ्लोइंग फ्रॉम दिस रीजन टू दिस रीजन। और तब तक ये फ्लो करेगा जब तक कि ये दोनों हाइट क्या हो जाए, सेम ना हो जाए। दैट मीन्स ये लिक्विड का प्रॉपर्टी है कि अपना हाइट जो है वो खुद ढूंढ लेता है, चाहे लिक्विड का, चाहे जिस शेप में रखा गया हो लिक्विड को, उससे कोई मतलब नहीं है। ये देखिए शेप जो भी हो, लेकिन ये देखिए अभी हाइट डिफरेंट होने का कारण है कि यहाँ वाल्व है और इस वाल्व के थ्रू लिक्विड यहाँ से यहाँ नहीं फ्लो कर रहा है, लेकिन वाल्व जैसे ही ओपन हो गया, वाल्व को हटा दिया गया, तो लिक्विड देखिए दोनों ये में केबिन में आपका डिस्ट्रीब्यूट हो गया और हाइट सेम हो गया। सेम वे, ठीक उसी तरह से यहाँ पर हमारे लिए पोटेंशियल के लिए भी ये रूल अप्लीकेबल है। चार्ज डिस्ट्रीब्यूशन, here charge distribution till potential of both conductors become equal. Here this is charge is Q1 and here charge is Q2, and here two different spheres having charge Q1 and Q2. यहाँ देखिए कि दोनों के बीच कोई कनेक्शन नहीं है। If here there is connection, जैसे ही हमने एक कनेक्शन रख दिया, this is radius R1 and this is radius R2, here radius R1 and here radius R2, जैसे ही दोनों को हमने कंबाइन कर दिया तो चार्ज का कुछ इस तरह से डिस्ट्रीब्यूशन होगा ऑटोमेटिक, नेचुरली, कि पोटेंशियल दोनों का क्या होगा, सेम हो जाएगा धीरे धीरे चार्ज ट्रांसफर होकर। एंड इन दिस केस हियर चार्ज विल बी Q1 डैश एंड हियर चार्ज इज Q2 डैश, जबकि पहले वाली सिचुएशन में हियर चार्ज इज Q1 एंड Q2। दैट मीन्स यू कैन से Q डैश इज डायरेक्टली प्रोपोर्शनल टू C। चार्ज का डिस्ट्रीब्यूशन कैपेसिटेंस पर डिपेंड करता है, डायरेक्टली प्रोपोर्शनल टू कैपेसिटेंस। दैट मीन्स Q1 dash by Q2 dash is equal to, you can write here, C1 by C2, capacitance of the capacitor. This is C1 by C2. That means you can write C1 by C2 is equals to R1 by R2. This is equals to R1 by R2. साइज बड़ा होगा, रेडियस बड़ा होगा, and total charge is Q1 plus Q2. Total charge is Q1 plus Q2, and here Q1 dash is equal to C1 divided by C1 plus C2 bracket, this is Q1 plus Q2, and this is equal to R1 divided by R1 plus R2 bracket, and this is again Q1 plus Q2, and here Q2 dash, this is Q2 dash is equal to here C2 divided by C1 plus C2 bracket close, and this is into Q1 plus Q2, and this is equal to R2 divided by R1 plus R2 bracket Q1 plus Q2. Now, loss of energy during redistribution of charges. जैसे ही चार्ज डिस्ट्रीब्यूट होता है तो there is a loss of energy. Now we are going to find how much will be the energy loss during the redistribution of charges. Now let us see loss of energy during redistribution of charge. We can show that in redistribution of charge, energy is always lost. That means here you can write, we can show that during redistribution of charge, energy is lost. Energy is always lost. Initial potential energy, initial potential energy is equal to half Q1 square by 2C1 plus half Q2 square divided by 2C2. This is initial potential energy. And final potential energy is equal to half, and this is charge will be Q1 plus Q2. This is Q1 plus Q2 whole square, and your capacitor का capacitance जो होगा this is C1 plus C2. This is C1 plus C2, and this is Q1 plus Q2 whole square. Now change in potential energy is equals to del U, and del U is equals to UI minus UF, and here UI is equals to half, this is Q1 square by 2 C1 plus half, this is Q2 square divided by 2 C2. This is initial potential energy minus this is half, this one is Q1 plus Q2 whole square divided by C1 plus C2. Now you can subtract taking half common ले लेते हैं इसको. This is equals to this is Q1 by C1, Q1 square by C1 plus this is Q2 square by C2 minus this is Q1 plus Q2 whole square divided by C1 plus C2. Now after solving you will get this value is equals to C2 square divided by 2 C1 C2 bracket C1 plus C2, and this is Q1 square by C1 square plus Q2 square by C2 square minus 2 Q1 by C1 Q2 by C2, and you know the formula here, this is Q equals to CV. That means you can convert Q1 by C1 is equal to V1, Q2 by C2 is equals to V2, Q1 by Q2 V1, Q2 by C2 V2. Now you can write this result in terms of potential. Final result in terms of potential C1 C2 divided by 2 C1 plus C2, and this is here V1 square plus V2 square minus 2 V1 V2. This is the formula in terms of A minus B whole square, A square plus B square minus 2AB. Now you can write this result. Here always remember C1 and C2. Here C1 and C2 and V1 minus V2 whole square are positive always. This is always positive always. C1, C2 and V1 minus V2 whole square is positive. So del U is always positive. That means del U is positive. That means UI is always greater than UF. That means you can write there is decrease in energy. Hence energy is always lost in this redistribution of charge. That means you can write here del U is equal to 0 if V1 is equal to V2. Here question is two isolated spherical conductors having radii 5 cm and 10 cm respectively. They have charges 12 microcoulomb and minus 3 microcoulomb. Find the charges after they are connected by a conducting wire. Also find common potential after redistribution. Now let this is sphere 1 having radius R1 and charge is 12 microcoulomb. This is, and here charge is positive, positive, positive. Let positive, and here another sphere. Let this is another sphere of radius R2. Let this is R2, and having charge is minus 3 microcoulomb. That means negative, negative, minus 3. Now attach this with your conducting wire. That means your figure will be, this is a sphere having radius R1, and this is sphere 2 having radius R2, and this has charge after redistribution. This is Q1 dash, and this is let Q2 dash, and having the common potential, and that is V and V. After redistribution or connection, your potential will be same. So this is the figure. Now you have to find Q1 dash, Q2 dash, and common potential V. Net charge is equal to 12 microcoulomb minus 3 microcoulomb. That means this is 12 minus 3 microcoulomb. That means this is 9 microcoulomb. This is your net charge. Charge is distributed in the ratio of their capacities or radii in the case of spherical conductor. That means you can write Q1 dash is by Q2 dash is equal to R1 by R2, and here R1 and R2 are here 5 centimeter and 10 centimeter. That means you can write 5 by 10, that means 1 by 2. This is. Now Q1 dash is equal to your Q1 dash is equal to here 1 by 1 plus 2. 1 by 1 plus 2 into your total charge, and this is 9 microcoulomb. That means 9 by 3, and this is 3 microcoulomb. Now Q2 dash is equals to here, this is 1, now this is 2. That means 2 divided by 1 plus 2 into 9, and this is equal to 2 by 3 into 9. That means this is 6 microcoulomb. Now what will be the common potential? For common potential, you know, V is equal to Q1 plus Q2. Q1 plus Q2 divided by C1 plus C2. Q1 plus Q2 is here given. Now your common potential is equal to your total charge will be 9 into 10 to the power minus 6. 9 into 10 to the power minus 6, and here this is C1 plus C2. That means you can write 4 pi epsilon naught, and this is R1 plus R2. Now put the value here, you will get, this is 9 into 10 to the power minus 6, 9 into 10 to the power minus 6, and 1 by 4 pi epsilon naught is 9 into 10 to the power 9 divided by your R1 plus R2. That means 10 plus 5, 15 into 10 to the power minus 2. This is 15 into 10 to the power minus 2. After simplification, you will get the common potential V is equal to 5.4 into 10 to the power 5 volt. This is your answer. There are two laws in capacitor. Here, like an electric current having resistance and battery, in the circuit containing capacitor, the Kirchhoff's law can be applied in the manner discussed below. First law, this is basically the law of conservation of charge. Following 2 points are important regarding the first law. In case of battery, both terminals of battery supply equal amount of charge. Second, in an isolated system, the meaning of isolated system is not connected to either of the terminal of battery or to earth. Here, in an isolated system, the net charge remains constant. These are the 2 points you have to remember always. This was your first law. Now this is second law. In second law, in a capacitor, potential drops when one moves from positive plate to negative plate by Q by C, and in a battery it drops by an amount equal to EMF of the battery. Let us see the example. In this example, in the figure shown, the positive terminal of battery supplies positive charge, and that is Q1 plus Q2. This is here positive charge, this is positive charge, and this is positive charge. So positive charge is here Q1 plus Q2. Positive charge is Q1 plus Q2, and negative terminal supplies negative charge of the magnitude. Here negative charge is Q3 and this is Q4. This is negative charge, and this is Q3 plus Q4. That means you can write Q1 plus Q2 is equal to Q3 plus Q4. That implies Q1 plus Q2, sum of positive charge is equal to sum of negative charge, that is Q3 plus Q4. You can write. Further, the plates are enclosed by dotted lines. This is your dotted line here. This is the plates are enclosed by dotted lines, form an isolated system, and they are neither connected to a battery nor to the earth. That means you can write initially no charge was present in these plates. Hence, after charging, the net charge on the plate should be 0. Or you can write here Q3, this is Q3 plus Q5 minus Q1 is equal to 0. In this figure, you can write this is here. This here charge is your Q5. Let here charge is Q5. This is positive charge, and this is here positive charge. And Q1 is negative. This is negative, this is positive, and this is positive. तो देखिए इस लूप में देखिए यहाँ पे एक लूप बन रहा है. इस लूप पे ध्यान देंगे. यहाँ पर इस लूप में देखिए ये कैपेसिटर का इस प्लेट नेगेटिव प्लेट को लिए है, इसके पॉजिटिव प्लेट को लिए, इसके पॉजिटिव प्लेट को लिए है. ये पॉजिटिव चार्ज इज हियर Q5, तो Q5 है ये, एंड दिस इज पॉजिटिव चार्ज इज हियर Q3, तो Q3 हो गया. एंड दिस इज नेगेटिव चार्ज इज हियर माइनस Q1, एंड हियर सम इज इक्वल टू 0. And again, for the second loop, here there are your relation, and this relation is your minus Q5 here, minus Q2, and plus Q4 is equal to 0. Here this is Q4 minus Q2 and minus Q5 equals to 0. That means here there are 3 equations. Equation number 1, this is equation number 2, and this is equation number 3. 3 equation and 3 unknowns. That means you can find your Q1, Q2 and Q3. These 3 equation can be obtained from the first law. तो इसको first law से हम इसको लिख भी सकते हैं इसको. Now, second law, in capacitor, potential drops when one moves from positive plate to negative plate, and it drops by Q by C. And in battery it drops by an amount equal to EMF of the battery. Applying second law, you can write in circuit applying second law in circuit, in circuit A, B, G, H, E, F, A, B, G, H, A, B, G, H, E, F, A. In this your loop, A, B, G, H, E, F, A. In this loop, you're applying second law. You can write here minus Q1 by C1 minus Q3 by C3 plus V is equal to 0. This is V, that means this potential, and here Q1 by C1. This is Q1 by C1. Q is equals to CV. Q equals to CV. So V is equals to Q by C. V equals to Q by C. Here potential drop will be Q1 by C1, and here potential drop is Q3 by C3, and plus V is equals to 0. This is from second law. Next, second law in loop. Second law in GCDIG. GCDIG. Here this is minus, and using this second law in GCDIG, in this loop, you can write minus Q1 by C1 minus Q5 by C5 minus Q2 by C2 is equal to 0. Here there are two equations using second law, and you can write, and there are two loop, one bigger loop A, B, G, H, E, F, A, and second one is G, C, D, I, G. Find the charge on the three capacitors shown in the figure. Here three capacitor, 1, 2 and 3. This is your battery 10 volt and this is 20 volt. Find the charge on three capacitor shown in the figure. Charges supplied by 10 volt battery. Let charges supplied by 10 volt battery is Q1. Let charges supplied by 10 volt battery is Q1. Let Q1 charge is supplied by your battery 10 volt, and from 20 volt battery is Q2, and from 20 volt battery is your, let Q2. Now here you can write Q1 plus Q2 is equal to Q3. You can write Q1 plus Q2 is equal to Q3. This is important relation, and this relation can be obtained in different manner. The charges on the three plate which are in contact, let this is, इसको हम कैसे फाइंड आउट कर सकते हैं? तो देखिए यहाँ पे let this charge is Q1 is here. Q1 चार्ज को हम यहाँ रखते हैं. Q1 charge. This is your let positive plate. This is negative plate. Again this is here negative plate. This is positive plate. This is here positive plate. This is here negative plate. And here charge is your Q2. And here charge is your Q3. That means you can write here in this loop. देखिए एक loop बन रहा है. This is negative, and this is here positive in this loop. In this loop you can write here Q3 is positive one side, and this is Q2 and Q1 and Q2 both are negative. That means you can write minus Q1 minus Q2 is equal to plus Q3 is equal to 0. That means you can write Q3 is equals to Q1 plus Q2. So this is very important relation, and you can write it from first law. The charges on the three plates which are in contact add to 0. because these plates takes together to form an isolated system which can't receive the charges from batteries. That means you can write, and from this equation you can write Q1 plus Q2 is equals to 3. Now applying second law in loop BCFAB, applying loop law, that means second. Now here applying second law in loop BCFAB, you can write here minus, this is minus Q1 by 2 minus Q3 by 3, this is here potential Q3 by 3, and plus 10 is equal to 0. In this loop, this is here, this is charge and this is capacitance. You know Q equals to CV, so V equals to Q by C, and this is here potential, this is potential. Second loop C D E F C, second loop C D E F C, you can write here Q2 by, this is Q2 by 4, this is Q2 by 4 minus 20, this is higher to lower, so minus, this is 20, and this is here, this charge is here Q3, so you can write Q3 by 6, this is plus Q3 by 6 is equal to 0, and after simplifying this two equation you will get here, इक्वेशन में आप एलसीएम लीजिए, एलसीएम लेने के बाद आप सॉल्व करेंगे, यू विल गेट, एंड दिस इज Q3 प्लस 3Q1 इज इक्वल टू 60. टेकिंग एलसीएम लेने के बाद आप सॉल्व करेंगे, यू विल गेट दिस इक्वेशन, एंड फ्रॉम दिस इज हियर 3Q2, एंड टेकिंग एलसीएम 3Q2 प्लस 2Q3 is equal to 240. This is another equation. After solving this three equation, here Q3 equals Q1 plus Q2, and second equation comes from this, that is here Q3 plus 3Q1 is equal to 60, and third equation is from this loop law, and this is 3Q2 plus 2Q3 is equals to 240. You will get the value of Q1, Q2 and Q3 of Q1 is equal to 10 by 3 microcoulomb, 10 by 3 microcoulomb, and you can match your answer. आप उसको solve कीजिए, and after then you can match your answer, and मैं इसको direct यहाँ लिख दे रहा हूँ, and this is Q2 is equals to 140 by 3, this is 140 by 3 microcoulomb, and Q3 is 50 microcoulomb, is 50 माइक्रोकूलम. तो आप इसको सॉल्व कर सकते हैं. सॉल्व करने के बाद तीनों इक्वेशन को यू विल गेट द आंसर